All right, guys, how we doing? So sorry I had to cut our content short today, but I wanted to make a quick video about greatest common factors, just to kind of pick up where we left off in class today and give you guys the rest of that information. So we talked about greatest common factor, right? And it is the largest factor that two numbers have in common. So the largest factor that two numbers have in common. So let's look at some examples here. Let's check out, I don't know, 16 and 20. Okay, so there's two different ways that we can find the greatest common factor. The first way is to list all of the factors, list all factors. And when we do that, we'll be able to see which factors the two numbers have in common. That looks more like a C than an L, so I'm going to rewrite that. We'll be able to see what factors the two numbers have in common, and then pick the largest one as the greatest common factor. So let's do that real quick. So let's list all of the factors of 16 and 20. So we know that 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. So now we know that all of our factors for 16 are 1, 2, 4, 8, and 16. We want to list them in order from least to greatest so we can see which one is the biggest common factor once we get that far. So now let's do 20. So we know, again, 1 times 20 is 20. Every number will always have factors of 1 in itself. 2 times 10 equals 20. 4 times 5 equals 20. So our factors of 20 are 1, 2, 4, 5, 10, and 20. So looking at these side by side, we can easily see that our common factors are 1, 2, and 4, and our greatest common factor is 4. So we know that our GCF of 16 and 20 equals 4. So that's one way we can find the greatest common factor, by listing all the factors and choosing the biggest one that they both have in common. But there's another way to find the greatest common factor, and that is through what we call prime factorization. Prime factorization. And what that means is we want to take a number and reduce it to its prime factors. And a prime factor is a factor of that number that is prime. And what prime means is that number has factors of 1 and itself only. 1 and itself only. That's very important. So for example, 3 is prime because 3 only has factors of 1 and 3. Its only factors are 1 in itself, so 3 is prime. So let's take a look here. We can use the same two numbers just for consistency's sake. We'll do 16 and 20. So let's reduce 16 to its prime factors. Well, we know that 4 times 4 is 16. You can start by just reducing it into two different factors. And then we further reduce those two factors into their factors. So 4 has factors of 2. 2 times 2 is 4. We do the same thing for this 4. 2 times 2. Now 2 is a prime number. It only has factors of 1 and 2. So this is reduced to its prime factors. 16's prime factorization, what we call it, is 2 times 2 times 2 times 2. So that's the prime factorization for 16. Now we want to do the same thing for 20. And I'll do this over here so I have more room. So let's start with 2 factors of 20. Let's do 2 and 10. So 2 times 10 is 20. 2 is prime, so we don't have to do anything with that anymore. But 10 is not, so we can further reduce that. Let's do 2 times 5. 2 is prime, so that can stay. And 5 is also prime. Its only factors are 1 and 5. So we bring this other 2 down, and the prime factorization of 20 is 2 times 2 times 5. So what do we do with these prime factorizations? Well, we can look at them next to each other, or I like to do it, I like to put them on top of each other. So if we do 16's prime factorization down here, 2 times 2 times 2 times 2, and we do 20's prime factorization up here, we have 2 times 2 times 5. Well, we want to look at what these prime factorizations have in common. So these both have prime factors in common of 2 times 2. We can see that here. There's 2 2's in 16, there's 2 2's in 20, and everything else is different. So we know that the greatest common factor of 20 and 16 is equal to 2 times 2, or 4, right? I can rewrite that over here. Equals 2 times 2, it's also equal to 4. And that's the same answer we found using our first method. Both of these methods work for finding the greatest common factor. So I hope that helps. I hope that helps you with your activities for today and tomorrow. And I hope you have a great rest of your day. Thanks.